Alright, so this is section 1, problem number 5. And in this problem we have two cylinders. The height of each cylinder is 10, and the radius of the first cylinder is going to be 4. And they said that what's going to be the approximate and actual change of the volume if the radius changed from 4 to 4.2. So what's going to be the change? So for A, we're going to have the formula for the volume of the cylinder, which is pi r squared times the height. We're going to find the derivative of the volume, which is pi 2r times the height, and we're going to multiply it by the r to find the approximate change in the volume. Okay, so now we just have to plug in for the numbers. And this is gonna equal approximately 16 pi. So that's the approximate change in the volume. Now for part B, we need to find the actual change. And to find the actual change, we just find the volume of the first cylinder and the volume of the second cylinder and subtract to find the difference. So B equals pi r squared times h. So the volume of the first cylinder will be pi. R is 4 squared times 10. Volume of the second cylinder is going to be pi 4.2 squared times 10. Okay, so just plug that into the calculator and we should get approximately 160 pi and 176.4 pi. So now that we have the volume of each, we can subtract. So 176.4 pi minus 160 pi is going to be equal to 16.4 pi. And that is the actual change in the volume. And we can see the approximate change and the actual change are very close. So we can be sure that they are both correct. Now for part C, we're told that each inch cubed is equal to 6 ounces, 0.6 ounces of the substance. So 0.6 ounces per inches cubed. Okay. Now we find that first of all, we need to turn the approximate change at 16 pi and the actual change to actual numbers, which is going to be equal to 50.27 and 51.52 inches cubed. So since we're talking about volume, the unit's always going to be inches cubed. And so from there, we just have to find each value, which will be 0.6 ounces multiplied by 50.27 inches cubed. And now, since we're talking about per inches cubed, we can do the per, and these are going to cancel out. So we're gonna be left with ounces, and just plug that into your calculator, and you should get about 30.16, rounded up to the nearest tenth. So now we just do the same thing for 2. And for the second cylinder, we have 0.6 ounces per inches cubed times 1.53 inches cubed. And the inches are going to cancel out again. And we're left with 30.91 ounces. So this is going to be the approximate weight of the cylinder with the substance in it. Now for part D, we're asked that there's a weight limit to each product of 2 liters. 2 pounds. 2 pounds, it can't weigh any more than 2 pounds. If not, it's not allowed in the store. So what we do is we can convert the 30 ounces into pounds, or we can convert the pounds into ounces. And personally, I think it's much easier to convert pounds into ounces. So we know that 1 pound is equal to 16 ounces. So from there, we just have to find what 2 pounds equal to. So multiply 16 times 2, and that's going to be 32 ounces. And from there, we can verify that they both satisfy the limit, since they weigh less than 2 pounds. So that's it. Thank you.
Okay, so this is problem 14 of section 2, which is basically solving the integral. And the first integral says integral parenthesis 35x minus 14. Then it's multiplied by the cubic root of 5x to the second power minus 4x all to the fourth power. So the first thing we need to do here is, try to find something to substitute. So we take the parenthesis in the little cubic root, and it would be 5x to the second power minus 4x. So du of the derivative of the u would be 10x minus 4. So we can take out the 2 as a common factor, and it stays 2 times, parenthesis 5x minus 2. So coming back to the procedure question, we write the integral 35x minus 14 times u to the 4/3, which is the power 4 because it's the power to which the parenthesis is raised to, and the cubic root, times du over our derivative, which is 2 times 5x minus 2. I put it this way so it's easier to cancel out. Then we take out the 7 out of the we take the common factor out of this parenthesis, and it's 7 times 5x minus 2 times 4/3 du to the 4/3 times du over 2 parenthesis 5x minus 2. So there's something we can cancel out over here. So the 5x minus 2 is canceled and canceled. So we end up having 7/2 u to the fourth power to the power of 4/3, which is basically the cubic root of u to the 4 times du.
Hi, this is part 2 of problem 14, section 2, which we know we're solving for this integral here that my teammate previously explained. The first thing he did was identify u, which he noticed was this. So he then entered this cubic root into the parentheses, giving it a power of 4/3. So he then simplified as well this expression, multiply this by u, then multiply this by du, divided by the derivative of u, which in this case he used this process to get as a result 10x minus 4, which he then simplified to 5x minus 2. So that's what he placed there. Then he noticed that since this is on the bottom and this is on the top, he was able to actually just cancel this out. So he was left with 7/2. So 7/2 times u plus 1, because this is from the formula, times u. So 1 in this case has a value of 3 according to the denominator, so 3 plus 4, 7, 4, and 4 plus 3, 7 as well, so we know it's 7/3. So then he divided this by 7/3, then we're gonna multiply 7 times 3, it's gonna equal 21, and then we're gonna multiply as well the centers. We're gonna put that as a denominator, and then we're gonna be left with the u, 7/3, and that's gonna give us an answer of 2. This is equal to u, but in an antiderivative form, plus c, which stands for the constant of the integrals. Thanks.